My name is Martin. I will be presenting our paper. My other authors are not here, Daan, Kolkman, and Bert-Jan, Butijn. The title is Elementary Scenario Component Metric for Summarization Evaluation. I'll just get started. Before talking about the related work, maybe a bit of a background. So this work is based on my thesis, which I finished almost 2 years ago. And the thesis was initially started as research in multi-document abstractive summarization, but then evolved into this evaluation metric because I have an idea, and I'll talk a bit about this in a moment. If we look at the related work, so our metric falls into the content-based evaluation measures, which is like an intrinsic evaluation. Usually comparing some parts of the text in the summary with some other reference summaries or gold standard summaries to say. There are some basic statistical ways to do that, like cosine similarity, longest common subsequence. One of the most popular metrics in summarization, like Rouge, or some people also use Blow. That's like an n-gram matching approach, and also pyramids and LSA-based measures. These are very well established measures, but they have some disadvantages, I think, which are you need reference summaries, and writing reference summaries can be a bit subjective because usually these when people are generating like the gold standard summaries, it takes a lot of effort, and usually only one annotator generates a summary for a specific set of documents. And on top of that, it's also quite costly. So in terms of it is manual labor, and it requires a lot of time and actually people reading all the documents and just coming up with a good summary. And moving on, in the last years, there were some quite novel advancements in the evaluation measure for summarization or question answering or translation. Some of them are like BERT score, which is based on a BERT model, and QA Evolve and Quest Evolve, which are more focused on question and answering, but can be adapted for summarization as well. The problem with these is, not the problem per se, but the disadvantage is that they are quite computationally expensive because they require a separate large language model just for doing the evaluation. And also that means you would add some extra complexity to your NLP pipeline. We think about the real world application of this. So a little bit of background about what is the elementary scenario component. So the whole idea about the metric was based on the work of Professor Peter de Kock. It's called Anticipating Criminal Behavior using the narrative and crime-related data. So in his work, he does a very, very comprehensive look at narratives, scenarios, and all these things in the context of crime. And the main conclusion is that basically all relevant aspects of a narrative or a scenario can be described by a set of 12 elementary scenario components. And this translates to actually all creative arts literature. So not necessarily just crime, but also just books and novels and so on. These ESC 12 or Escape 12, they're the building blocks for any scenario. This is a list of all the 12 components. So if I can just think of a story or a news article about a crime event or something like that, and then you would be able to identify most of these. Usually there are 3 types of scenario components: objective, subjective, and interpretable. The objective ones are pretty straightforward. It's like where it happened, when it happened, who is the protagonist, who is the antagonist. The subjective ones are a bit more difficult. So, you need to figure out what's the motivation of the specific act or what happened and what was the goal. And the interpretable ones are the most tricky ones. So it's symbolism and red herring. And this is a bit more specific to crime events or just arts literature. yeah, this comes in all in place into our metric. So the main thing about our evaluation metric is that it doesn't require whole reference summaries, but it only utilizes these elementary scenario components to estimate the relevance of the model generated summaries. So the way to use a metric is, you need a few simple steps. The first part is to actually define the mapping between, I'll go back one slide, the mapping between these components and what you actually have in your domain. In our case, we work with a data set about homicide cases in the Netherlands. So then, in that case, the protagonist is, for example, the person that was involved in the crime or committed the act and so on. After you do your mapping, then you actually need to annotate some data. So the main advantage of the metric is that you would only need to highlight these ESCs for each document or set of documents instead of writing a whole gold standard summary. And this definitely saves a lot of time, and it's also more objective because annotators agree better on which set of or which words or engrams correspond to the arena or the other different components. And the final part is computing the metric. For that, we used fuzzy string matching. And this is the formal definition, but in essence, what it does is, for each of the different components, it actually checks if it is present in the summary and if it's present in the original document, and computes that ratio and averages it out over each of the components you've chosen and over the whole corpus of documents you have. So now I'll introduce you a little bit to the experiment and the whole setting. As I mentioned, this was based on my thesis, and then it evolved into this new evaluation metric. So originally, we did some different experiments with multi-document abstractive summarization of homicide texts. We had a homicide data set that consisted of 100 cases. So these are let's say, the most popular murder cases in the Netherlands. It was compiled by hand with domain experts from the police and also some companies in the security area, let's say. And there were on average 14 documents per case, which is plenty for multi-document summarization. We used a few different models, which was what was available was the state of the art at the time. So some transformer models, some other models, a model called HiMap from Fabriero and so on. For the operationalization part, we only selected 6 out of the 12 components. The main reason for that was because of the dataset annotation. It was mostly annotated with these. And also, as I mentioned, some of the components like red herring, they're not really present in all cases. It's pretty rare to have them. So we had a selection of components to actually use for our metric. This is also subject to change. Let's say for another domain, maybe you can use a different set of metrics. It wouldn't really make a difference. The calculation is identical. And once we had once we defined the mapping and we had all the annotations figured out, then you just compute the metrics. And we were quite happy with the results. And afterwards, we employed a whole human evaluation survey with domain experts. So this was done in partnership with the Dutch National Police, and I'll talk about this in a bit. So in the human evaluation survey, we actually evaluated the accuracy of our metric compared to how humans would rate the different components that are present in the text. And also we had some questions about the text quality and just how good the summary seemed. And now results. We found a strong positive correlation of 0.89 with human evaluations. So this, you can see that on figure 1 on the right. This was very good. We were quite impressed with the results. And we also did some inter-rater reliability measures with the human evaluation. And we also found that, basically all of the, for all the different cases we presented to people in the human evaluation survey, all of them had a positive coefficient. We used Krippendorff's alpha. For two of the documents, it wasn't that high, and for one of them, it was pretty good, so 0.6. The thing is that because we had some questions about the text quality, we found out that this is the topic where people disagreed more, and this is why also the measure is a bit lower. But people did definitely agree higher on the subject of comparing the metric versus the actually judging how good ESCs are measured in the text. We also did some manual work, and we wrote some code standard summaries ourselves on a few different cases. And we checked the correlation between our metric and Rouge for these cases, and also the human evaluation in Rouge. And we found out that they're also positively correlated, which was in line with the findings of the original paper of Rouge. So in that paper, for example, the Rouge SU4 is usually the measure with the highest correlation with human evaluation. And this was also the case for us for both our metric and just the human scores from the survey. So now a little bit about the limitations and some ideas for future research. So one of the main limitations, and this is also feedback we got from other scientists, is that this is a recall-based metric. So the one thing to look out for is, let's say if the produced summary is an exact copy of your input document, then you would get a 100% metric. So it is a limitation on one side, but also we do recommend this metric to be used alongside other metrics or as an initial step in your study or pipeline, or also just depending on your domain, it might be helpful. For example, in our case, for the police, they found it was really good, and it would save a lot of time. Instead of writing reference summaries, they would just have to annotate some data about the escape 12 components, or even they already had that for some cases. The other limitation is that we use fuzzy string matching, which is one way to do it. So we use maybe word embeddings or other approaches to actually look for the specific components in the summaries. And we had some thresholds. For example, we used the threshold of 70%. If the match was above 70%, then we took that as a match, and otherwise we discarded the component. And the last thing is that the data set was relatively small. So originally it was 100 documents, but actually there were only 26 documents that had all the necessary components annotated. And so we used 26 documents for the rest of the study. Some ideas for future research. Well, the first thing is to experiment with a different selection of escape 12. So as I mentioned, we only used 6. For another domain or another task, it would be nice to try out some more, maybe with some novels or just literature. You could also, it would be interesting to look into the red herring or the symbolism part. But we thought that's a part of future research. Another thing is also better entity mapping. So for example, with us, with the time frame, we use just a date format, which is day, month, year. Sometimes dates or timeframes are referred to in text, not directly, but things like last month and so on. So that's also something to look into. And the final part is the TAC 2010 dataset. It also has a part of it which is annotated in a similar fashion. So we thought maybe it would be interesting to adapt this a little bit to our flow and then compare how would our metric perform on the TAC 2010 dataset. To conclude, so we received our results showed a high positive correlation with the human evaluations. Our metric results in time savings when you are annotating data compared to writing reference summaries. That's one of the main advantages. And we think it's a good alternative to existing metrics when you have under-resourced application domains. As I said, with the police, they don't really have the resource to write reference summaries, so this was a good, a good experience for them. And also, when writing and evaluating summaries requires domain expertise, because maybe for news articles, a lot of people can just write generic summaries, but for specific domains like police data or medical data, then annotators would have to be domain experts. That's it. Thank you for your time, and if you have any questions.